calories. Now we are going to see the chemical reaction. So this is your chemical reaction. And we need to study basically three types of chemical reaction here. The first one is your nucleophilic substitution. The second is elimination reaction. And the third one is reaction with matter. Reaction with matter. Is that clear? So we are going to start this nucleophilic substitution reaction. So I think you have written it.
Yes, sir.
Okay. Let's go with the nucleophilic substitution reaction. You have studied this chapter, right? Or not?
Yes, sir. Yeah.
Okay. Do you have notes of it, or you are writing? You are making notes.
I have notes.
Okay. Okay. And see, this is that means basically I don't need to write all the theoretical parts, right? I just need to explain the mechanism behind the reaction, and we will do questions, right?
Yes, sir.
And whenever the questions you must write, and also if there is anything else you want to write, just let me know so that I will stop and you can write easy. Okay.
Yes.
Okay, so let's go to this name, nucleophilic substitution reaction. You know what does this substitution means, right? Someone will go and someone will replace that place. That is substitution, right?
Yes.
If you are sitting on a chair and your father comes, you just leave that chair and your father just sit there. That means your father replaced you or substituted you. That means substitution took place there. So that is substitution, and this is before that substitution. You can see this is your nucleophile. That means nucleophile will substitute. So we can understand it like this: nucleophile is here, and you know, I think nucleophile. You are aware of this nucleophile. That is nucleus lover. Nucleus lover. That means positive or positive nucleus lover, and it is also electron rich species. So it will love the species which is deficient, which have deficiency of electron. Okay, so we can see here there is a nucleophile, and this is like this, and this X is more electronegative, so there will be a delta negative and delta positive, and it will take electron from carbon, and it will, when this X will be taking electron from carbon, what will happen? It's very important to know. Carbon will have deficiency of electron because its electron is taken by X, which is also called leaving loop. So this nucleophile will attack on carbon. So this is what will happen. This X will be replaced by nucleophile and X will be. So this reaction is basically known as nucleophilic substitution reaction. Is that clear?
Yes, sir.
Also, it is very important to know that nucleophile can be neutral, and nucleophile is also your anion. It cannot be positive. Okay, so neutral like H2O you can call it, and anion like OH minus or Cn minus. So nucleophile can be divided into two categories: nucleophile having zero charge, that means neutral, and having negative charge, that is anionic nucleophile. Is that clear?
Yes, sir.
Now there is a term that is ambidentate, ambident nucleophiles. What does this mean? Basically, it has two nucleophilic center. That means a species which can attack from both sides. That is basically your Cn minus. Cn minus is like this C has a negative charge and N has a lone pair. So it can either attack from there and there. So it will use only one of it. And this type of nucleophile is known as basically your ambident nucleophile. Is that clear? You know that nitrogen makes triple bond with this and it has a lone pair and this has a negative charge. And you know, if someone has negative charge, that means it is electron rich species which can either attack from here and it can either attack from here. Is that clear?
Yes, sir.
So this type of nucleophile is known as ambident nucleophile. Moving to the next part, we have two types of nucleophilic substitution reaction, and the first one is we have basically SN1, and we have the second one which is known as SN. So we are going to deal with the first one, second one, which is SN. SN2 is basically substitution nucleophilic bimolecular. Substitution nucleophilic bimolecular. Do you know what does this bimolecular means? As you already know, basically substitution and nucleophilic means what? And but do you know what is bimolecular? Have you studied chemical kinetics?
To
Yeah, that's good. By that
second rate of reaction.
What you just said.
Is it like second rate of reaction?
Second, I couldn't get it. Rate? No. You are studied in chemical kinetics, order of reaction and molecularity of reaction. So order of reaction can be fraction, 0, and positive integer, and this molecularity can only be positive integer. So molecularity is the interacting molecules. That is called molecularity. If one molecule is reacting a species, one molecule, that means unimolecular. If two, then it is bimolecular, and if three, termolecular. Are you getting my point?
Yes, sir.
This SN2 is basically bimolecular. That means two molecules will be reacting with each other. Now I'm going to show you this reaction. Wait a minute. Now, as you can see, this is your OH minus. Can you tell me what it is? It is nucleophile, and there is CH3Cl. That means I'm going to represent it. You know, this is in 3D tetrahedral, and also you know this is Cl. Cl is what? You know, this will have delta negative charge, so it will take electron from carbon. I'm going to show you the intermediate. What will happen when carbon will try to take electron from chlorine will try to take electron from carbon. Carbon will be having deficiency of electron, so this will attack on this. So I'm going to show you. This is gonna break. That means the bond between, wait a minute, the bond between, wait a minute, please. So as you can see, this bond gonna break. That's why I'm showing you with the dotted line. And there is hydrogen, and then there is hydrogen, and then there is hydrogen. Now, if this gonna break, then this OH minus gonna add with this. So I'm gonna write it. So this is the intermediate. I just showed the reaction. And after this, you can see this is your carbon, which is, and then this OH will be like this, and then this is the product you will get. So as you can see in this reaction, you have two reactant, two molecule, OH minus and this CH3Cl. That's why it is bimolecular. Is that clear?
Yes, sir.
So this is how SN2 took place. Now it's very important to learn the mechanism or the rate of reaction. So in this, there is no formation of carbocation take place. That means it is a single step reaction. Are you getting my point? Single step reaction.
Yeah.
Okay. Now I would
Unimolecular
like
is
to,
two-step, right?
yeah, unimolecular two-step reaction. That is yes and no. Now I would like to ask you a question. This is your CH3 and then CH2 and then X. And this is your CH3 and then CH and then CH3 and this is your X. And this is your CH3 and then C. This is your C. And this is your CH3 and this is your CH3 and this is your X. As you know, this is your primary, this is your secondary, this is your tertiary. Now, can you tell me OH minus can easily attack on which of this primary, secondary, tertiary? OH minus can attack on carbon. Which carbon? Primary, secondary, or tertiary?
Primary.
Primary. Why it is so?
Because concentration is less.
Concentration, what does this mean? Concentration we always use for molarity generally. 1 degree, 2 degree, 3 degree. The term you used is wrong. We will use steric hindrance or crowd. As you can see, if I'm going to write it in an open structure, so there will be C, H, H, and H. There will be H, H, H. Now, if I'm going to use this, this is your H, this is your H, this is your H. In the same way, if you are going to write this, there is crowd, bulky group is there, and if OH minus wants to pass from here, it will face problem of repulsion. That's why this will be reacting faster than this. Are you getting my point?
Yes, sir.
And if you are going to write this CH3X, that means this is super primary, what we call super primary. This will have the most, this will be the most reactive among these four because it has only hydrogen surrounded around carbon. But here it is CH3 and 2H. Here it is 2 CH3, 1H. Here 3 CH3. Can you change the slide? So there is a point that I have written: single step reaction, 1 degree, 2 degree, 3 degree. This is the reactivity towards SN. Is that clear?
Okay, sir.
Also, it is very important to note that iodine is the best living group, then bromine comes, then fluorine comes, then fluorine. This is the best living group. Best living group, that means if X is, if I'm going to compare this with, let's say, if I'm going to compare this with CH3, if degree are same, can you tell me which one is more reactive? You can see all are super primary. Which one is more reactive? The one with the high iodine, because this is the best living group. If it will not go, how the reaction will take place? And it can, if it is, if it goes easily, that means it is reactive. If it will go, then reaction will occur. Yes or no?
Fluorine is like most electronegative.
That is most electronegative, but iodine is best living group. See, if you are going to react this with OH minus, all are with OH minus, that means nucleophile. If you are going to react this with OH minus, okay, just concentrate here, and this will attack on carbon. When it will attack on carbon? When if either fluorine, chlorine, bromine, or iodine will take electron from carbon and go. After taking electron and going, then OH minus will attack easily, which can take electron, this iodine, because its bond length is lengthy. That means bond length is inversely proportional to bond strength. The bond strength of CH3F is very high. Are you getting my point? And also we know that the best living group is iodine. Iodine can easily go. If it will easily go, then that means it is going faster, it is living faster. OH minus can easily attack. This is slightly slow, so OH minus will slightly attack slow. most slow, that means it will attack most slow. This is the most slow. Are you getting my point?
Yes, sir.
Very good. So we have studied about the SN2 single state reaction, and also it is very important to note that SN2, in SN2 we do back attack. Back attack. Do you know what does this back attack means? If you are going to react this, this reaction, if you are going to, you have studied chemical kinetics, right?
Yes, sir.
So at the end of the chapter, when you have studied collision frequency, so there were two conditions. One is bulky, that is a steric hindrance, and another is proper orientation. If you are going to react this in this way, just focus here. So this will be going in the negative, right? Yes or no? And this will be attacking on here, and it has negative charge. And this comes in the same way. This I minus and OH minus. Will it be possible to come together and come near to each other? OH minus and I minus. Yes or no? Whatever is in your mind, just let me know.
No.
No. Why? There is always why.
The these seven reactions happen from like back, right?
What you just said, I couldn't get you.
No, OH should be on this side, on the left side.
No, that we will discuss later. Why it it cannot attack from front side on carbon? See, it's very
Carbon is full, the valence is full.
no. If I minus will leave this carbon, it will have negative charge, and OH minus is having already negative charge. So if they are coming closer to each other, that means negative negative. Can
Will
it come
repel.
together? It will repel each other. So that's
Yeah.
why in SN2 front attack is not possible. That's why OH or nucleophile attack from back side. And that's why inversion takes place. Inversion, do you know what is inversion? It's very simple. Firaz, if you don't know, just do reply me.
No.
Okay, come here. Inversion is the whatever is the configuration in reactant that will be totally invert. That means that will be totally opposite in product. As you can see, Cl is on the plane. This is the configuration. You can see this is dashed and this is wedge. This is tetrahedral. Tetrahedral has two bonds on the plane, one inside the plane and one outside the plane. Yes or no?
Yes, sir.
So as you can see that this is on the right hand side, but after reaction it is on the left hand side. So it is inverted. You can see the arrangement of bonds in reactant as well as product. So by the attack, by the back attack in SN2, inversion takes place. Is that clear?
Yes, sir.
So this is the concept you need to learn is very important. This is what you need to learn. Okay. So we are here with this. We did with this. Okay. Let's go to the SN2. So first of all, I'm again going to show you this is the 1 degree, 2 degree, 3 degree, and before this CH3X is the reactivity, single state. It's very important, and also inversion takes place that we will now learn in optical isomerism. Okay, and also back attack take place. Now come to the next point, that is SN1. SN1 is basically your substitution. I'm going to write substitution as like this, and nucleophilic unimolecular reaction. Unimolecular, that means single reactant reacting. Okay, so I'm going to show you in a single step, but this is in two-step reaction. So in a single step, I want to show you this CH3 whole CH3 whole thrice. Oh, wait a minute. CH3 whole thrice, and this is Br. And you are going to react with this OH minus, and it will give you CH3 whole thrice. and this is C, OH, and Br minus will leave. Now come to this point. This is in a single step, but this reaction takes place in two steps. So see how this reaction takes place in two steps. First of all, this is your whole twice carbon Br. Br is more electronegative. So what it will do? This is your step one. So in the first step, bromine will take electron from carbon and it will, as you know that this has 3 CH3, which is tertiary. This is carbocation because it took electron from. So this is the scenario you can see. So it is C positive carbocation. So you can see in this reaction only one molecule is there. So it is unimolecular. Now in the second step, what will happen? It's very easy to understand. This is carbocation, this is CH3, this is also CH3, this is also CH3. And OH minus will come, that means nucleophile will come, and this is your step 2, in which this OH minus either can attack from here and OH minus either can attack from here, and it will form like this. CH3 whole thrice C. So it's very easy to understand the reactivity. As we know that since carbocation formation is taking place, that means 3 degree, 2 degree, 1 degree is your, or you can say CH3X is your reactivity series. This is not a single step, it is double step reaction or two-step reaction or two-step reaction. And we will see about inversion, and basically racemization takes place here, and front side, back side, both attacks takes place here. Is that clear?
Yes, sir.
So it's very easy to understand. Do you know how to do the resonance? Can you write the resonating structure?
Electrophilic substitution.
No. A resonating structure of this compound. I'm going to show you. Can you write the resonating structure of this? Will you be able to solve it?
Yes, but I don't know like how to show.
Okay, no problem. So whenever there will be conjugation, like you can say pi pi sigma, and then there is vacant orbital, that is C positive. So what will happen? So this will let me show you from this side because I am righty, so it will be easy for me. This is the scenario. As you can see, this bond will be moving to this, and since this carbon is giving its electron, so it will have now positive charge, and there was already single bond, so it will be double, and it is like this, and the rest are like this. Again, this will move to this, so positive charge will come to this, and as you can see, this will have positive charge, double bond move to this, and this was there, and this was there too. Again, this will move to this, so positive charge will be there. Have you done it in previous class? 11th, you have done it this. You have done this, right? Double bond CH2. And also it's very important to note this will be moving on this. So it will move to this. Delocalization of my bond took place. This is called resonating structure and the process is resonance. And resonance stabilizes the molecule. You have done it or not?
Yes, sir.
Okay. Okay, can you tell me which one is more reactive towards SN2? This is your scenario, CS2Cl, and which one is more reactive towards SN2? First or second? Towards SN2, I'm asking. First, you are going to do for SN2, and then you are going for SN1. This is your A, this is your B.
For SN2, Cl is more reactive. And B
A or B? Just let me know A or B. For SN2, which one is greater? A, because it is 1 degree and this is 2 degree. And for SN1, it is B greater than, right?
yeah.
Okay, let me tell. This is your I, A, and this is your BR. This is your A, and this is your B. Can you tell me for SN1 and SN2? For SN1, which one will be greater? Am I audible? Firaz, can't you do it? You can see this is 1 degree, this is 1 degree. When degree are same, then go for the living group. Iodine is the best living group. So in SN1, A is greater than B, and in SN2, A is greater than B. Because both have same alkyl group, so we will go for best living group. And I'm again going to write Ri is the best living group, or you can say reactive RBr, and then RCl, and then RF. Is that clear? Firaz, am I audible?
Yes, sir.
Can I change the slide? Did you get it or not?
Yes, sir. It's same order in both reactions. Right?
Yeah. That is because both are same degree. So we will go for living group. Okay.
Yes, sir.
Now we are going to do the stereochemical aspect of stereochemical aspects of nucleophilic substitution reaction. SN reaction. I'm going to write nucleophilic substitution reaction. That means SN reaction. So here is a term that is optical activity. Optical activity. So it's very easy to understand the optical activity. So what happens when a plane polarized light is produced, and there is that is basically plane polarized light produced by any ordinary light, and it is passed through a Nicol prism. Are you getting my point? A light which is passed through
Yeah.
Nicol prism, and basically, wait a minute, let me show you. There is a plane polarized light. It is going like this, and it is passing through plane polarized light. Wait a minute. how we terminate. From where I should write this. Okay. There is a plane polarized light that is going from Nicole prism, and there is a solution. There is a solution. There is a solution. I should write not like this because it's difficult to show you the. Okay. See, this is the plane polarized light. It is like this, a straight line. Okay. And if it is passed through Nicole prism, and there is basically certain solution of a compound. If you want to check it, whether the compound is active, optically active or not. So there is two possibility. There is two possibility. There is two possibility. First possibility is basically either this plane polarized light will rotate, and the second possibility is either the plane polarized will not rotate. That means it will be in the same direction. Are you getting my point? If it will not rotate, that means the compound is optically inactive.
Yes.
That clear? And if
Yes.
it will rotate, it will have two.
Clockwise,
Basically,
anti-clockwise.
yes, clockwise or anti-clockwise. So this is your anti-clockwise. It will rotate anti-clockwise, and this is your clockwise. So if it will rotate clockwise, that means dextro-rotatory. You have heard of this, right? Dextro-rotatory, and this is denoted with D or plus sign. And if it will rotate anti-clockwise, that is levo-rotatory, and that is your basically L or negative. Is that clear?
Yes, sir.
So this is how we do. This is how we do. How we know whether it is optically active or inactive in laboratory. So basically, we need to know which is optically active and optically inactive. So in order to know this, we need to know some terms like chirality, enantiomer, and chiral achiral. Have you heard of this?
Yes, sir.
Okay. So let's start our chiral and achiral. So for chiral, it's very important to know that we are going to talk about chiral carbon or chiral compound. Carbon should be sp3. First condition is carbon should be sp3 and should be surrounded by four different groups. Should be surrounded by four different groups. And any one of them is violated, that is called a chiral carbon. Are you getting my point? If I'm going to ask you, can you say whether which carbon is chiral in this compound? See, this carbon is connected with three hydrogen. That means it is not chiral because three hydrogen. First of all, you need to check the hybridization. This is sp3, and I think all are sp3 hybridized carbon because all are singly bonded. So now you need to take care of the groups. So same group, that means not chiral. Same group, because this is hydrogen, same group, that means not chiral. Same group, that means not chiral. Come to this point, which is your this part. So as you can see, this is different group. This is also different group. This is totally different groups, and this is also totally different group. So this is the point where it is chiral. Are you getting my point?
Yes.
So this is how we see chirality and achirality. There will be question which one of the following is chiral and achiral. So you need to check. First of all, you are going to check for the hybridization, and after that you need to check whether it is surrounded by different groups or not. If it is surrounded by four different groups, it is chiral, and if it is not surrounded by different groups, it is not chiral. Is that clear?
Yes.
If I'm going to ask you a question, which is very easy, this is your CHO, this is your H, this is your OH, this is your OH, this is your H, this is your H. Let me just slightly make a difference between them. OH, H, OH, H, OH, H, and then again OH, and then H, and CH2. Can you tell me how many chiral carbon are there in this chiral center?
From down the first one, that's the one.
This is your chiral. Next.
The next one is also chiral.
Next.
Next one also should be chiral.
Should be not. It is chiral. This is also
Yeah,
chiral.
last also
Is it
chiral.
chiral? Is this chiral?
No.
Why? Tell me the reason.
It has only 3.
What 3?
No. There's a CHO, an OH, H, and one more H. There's
What
2
do you
H
want
groups.
to? Are you talking about this?
Yeah.
Yeah. So basically, it is not chiral because there is CHO, and which is sp2 hybridization. Not the reason that you have said. Are you getting my point?
Yeah. Right.
So it is sp2. Can you tell me why it is not chiral? The down carbon, the bottom carbon, the carbon on the bottom. Because it is connected with two hydrogen, right? As you can see, 2 hydrogen, same group. It is basically sp3, but it is connected with 2 hydrogen, same. That's why it is not chiral. Got it?
Yes.
Okay. So I'm gonna change the slide and gonna talk about this enantiomer. Do you know what is enantiomer? Yes or no?
They can't be like superimposed.
Non-superimposable mirror image. Very good. Then it cannot be superimposed. Non-superimposable. Superimposable mirror. That is your basically enantiomer. Now come to the point. This is non-superimposable mirror image. So I'm gonna show you a compound in NCERT. It is given that this is your CH3, this is your C2H5, and this is your H. And if you're going to put a mirror here, so you know it will be in opposite direction, it will be inverted, right? Which will be on the right hand side, left hand side now, and this will be on the right hand side. You know how the configuration will be in mirror, right? Are you getting my point?
Yeah.
If you're going to rotate it through 180 degree, this is OH and this is your C2H5. It will be same as the previous one. It will be it will not be same basically because it is having different group. And this is your H. So as you can see, this and this, are they superimposable or not? Are they superimposable or not? They are not. That means they are basically what?
Enantiomers.
This is how we do. Now there is a term that is racemic mixture. Racemic mixture, and we will talk about it after a while. Racemic mixture. So basically, it is something that is 50-50%. That means a compound which is dextrorotatory 50% and levorotatory 50%, and that is called a racemization. Are you getting my point?
Yes.
A compound which is dextrorotatory for 50% you are going to take, and levorotatory for 50%. equal in amount, and the mixture is known as your racemic mixture. So I'm going to
There
explain
will
this.
be
This
no
is a
rotation, right? There will be no rotation.
net rotation, you can see, is 0. There was rotation, but as you can see, if you're going to push me with a 500 Newton force, and I'm going to push you in opposite direction for 500 Newton, it doesn't mean that we are not applying force. The net force will be 0, right? There will be no movement, but force is applying there, right? Yes or no?
Yes.
Okay, I'm going to take an example from NCRT, and which is easily determine all this retention. Do you know what is retention? The configuration before reaction and after reaction is same. What is this configuration I'm talking about? I'm talking about the spatial arrangement of the bonds are same. That means retention is taking place. Are opposite, that means inversion took place. Is that clear?
Yes.
And racemization means if you are going to take this invert retention and inversion, and you are going to mix this in equal amount, then it will be racemization. I'm going to take an example which is very easy to understand. This is your C2H5. This will be your hydrogen, and this will be your, also this is your CH3, and this is your Y. Oh, I just wrote it. Wait a minute. I should take this. This is your C2H5, and then this is your CH3, and this is your H first, and this is your X. Now see what happens. If you are going to react this with Y, there is two possibilities. Either Y will just take place, either Y is just substituted X in the way I'm going to write it. Just focus here. Either Y will just replace X at the same place, or either Y will attack. See, this is your basically front attack, and this is your basically back attack. Are you getting my point?
Yes, sir.
If it will attack from back, the product is this. If it will attack from front, the product is this. Got it? It is just the reaction. That's why I'm writing it like this. Are you getting my point?
Yes.
Now, so as you can see that this is the configuration of this, and this is same. The X present wherever is now Y is present. So this is your A, which is basically a retention. That means it retain its its spatial arrangement. And now you can see the Y is where basically Y is opposite of the X. That's why it is inverse. Are you getting my point?
Yes, sir.
So if you can see this is clockwise, that means this is anti-clockwise. And if you are going to take this A and B in equal amount and mix them, then you will get racemization or racemic mixture. Are you getting my point?
Yes.
So this is how we do. It's very easy. Okay. So always remember that in SN2 we get what we get is inversion. Inversion takes place because of back attack. In SN1, racemization takes place. Racemization, because in SN1, back attack is also possible, front attack is also possible. So we will take both the possibility, and as you can see, from back attack it will be inverted, from front attack it will be retention. And if you are going to mix them, you will get racemization. Got it?
Yeah.
Okay, so this was about SN1 and SN2. We did SN2, which is two-step reaction, back attack, 1 degree, 2 degree, 3 degree. SN1, double step, two-step reaction, 3 degree, 2 degree, 1 degree, and front and back attack both. In SN2, inversion takes place. In SN1, inversion and retention both takes place, from where we can get racemization or racemic mixture. Got it? Now come to the next, and the reactivity is also very important. Come to the next, which is your elimination reaction. elimination reactions. In elimination reaction, what you need to do, it's very simple. It is also known as basically what we call it beta elimination. This reaction is also known as beta elimination. Do you know beta elimination? Now, how we are going to define this beta elimination or beta, what is this? So see, if this is the carbon from where X is connected, this is the carbon where X is connected. That means basically this is your alpha carbon. Are you getting my point? And the carbon which is connected with alpha carbon is your beta carbon. And the carbon which is connected with the beta carbon is called gamma carbon. And the carbon which is connected with this which is called delta carbon. Wait a minute. So you just don't need to think about all this gamma, delta. The most used in our syllabus is alpha and then very less beta. So this is your gamma and this is your delta. This is how we see alpha, beta, gamma, delta. So you need to think only about beta here. The carbon which is connected to the carbon which has X group, halogen. Are you getting my point?
Yes.
Now see, I'm going to show you the beta elimination reaction. That is, this is your hydrogen and this is what we have, X, and this is X. So what will happen? I'm going to show you like this. X is there. What will happen? This is your alpha, this is your beta. What will happen? This HX will be eliminated. X from alpha, hydrogen from beta will be eliminated with the help of some reagent. We will discuss about it, and it has 2 bonds left and it will be doubly bonded. So by elimination reaction in this halogen, haloalkanes, we will get alkene. And you know what will happen? It is not basically like this. There will be nucleophile. There will be nucleophile. What will happen? This bond will come here. Then hydrogen will have deficiency of electron. So this H will be going, and this is taking electron from here. Again, I'm going to explain in the second slide because it just made hotspots. Now see, this is your C, this is your X, this is your this. Right. Now I'm going to explain. Since X is more electronegative, what it will do? It will take electron from carbon. It will take electron from carbon and it will be in negative. Now, carbon will have deficiency of electron. So this carbon will support this carbon. In what way? Carbon is more electronegative. So it will take electron from this hydrogen and make bond with this carbon. Now, there will be deficiency of, yes, there will be deficiency of electron on this hydrogen. So there will be nucleophile waiting, or base, you can say B I am taking. Base is nucleophile, we can say, because base is base donates electron. B is here, so which will go with this. So what you will get? You will get this as a main product, then as a byproduct, this is what you will get. Are you getting my point?
Yes.
And this reaction will be taking place in the presence of basically what? Alcoholic KOH and heat. Are you getting my point? If there is any reaction which is alcoholic KOH and you are going to heat it, that means there will be elimination taking place and formation of alkene is there. Is that clear?
Yes.
Now I'm going to give you a question from NCERT. You are preparing for board first, right? CBSE. Yes or no?
Yes, sir.
So can you tell me? Wait a minute. Can you tell me the possible products? How many possible products are there? First, you need to decide the alpha beta carbon. Always remember. So our class is gonna be for 1.5 hours today, right? And in the last class, as I had to leave earlier before 10 minutes in the last class. So I will take this class up to 10:40. Will there be any problem?
No, sir.
Okay. Are you done with this, or should I explain? You are not audible. Firaz, am I audible? You are not audible. You can reply me in chat box because you are not audible at all. Or you may leave and join again if you want, whatever is.
Sir, can you hear me?
Yes, now I can hear you. Yes,
So it'll form like two
products, right? Yes, you can see there is basically this is beta and this is also beta. So I can write this like this. Oh, I just repeated it. So this is what we get. So what will happen? This bromine and this bromine will hydrogen will go. Then we will get CH3, CH2, and then CH2 again, and then CH double bond CH2. And if this will go, this
No, sir,
and this will go.
it's CH, right? CH.
Where is CH?
No, we
CH3?
form a CH3, right, in the end.
Here you want to write CH3.
Yeah, okay, sorry, this is pentwanine, yeah.
Yeah.
And then the other product is pentwine.
I removed first this and this. CH3,
Yeah,
CH.
yeah.
Minute. It will be.
Yeah.
Wait a minute. So I'm going to write CH2. Now this hydrogen I'm going to remove. So it will be CH and double bond CH and then CH3. Can you tell me which one is more stable? Which one will be major and which one will be minor?
Major.
Yeah, you are not audible. Clearly, basically your
Pentwine will be
voice-
major.
Why it is so? This is why measure. It is right answer, but why? See, there is two reasons that we can go for. Did you know how to calculate alpha hydrogen? Do you know how to calculate alpha hydrogen? So this is your, with respect to this alkene, This is your alpha carbon. With respect to this alkene and the hydrogen which is connected with this alpha carbon, basically two alpha hydrogen. And with respect to this alkene, we have two alpha carbon. This is alpha carbon and this is alpha carbon. And we have five alpha hydrogen. So the compound which is having more alpha hydrogen is the one which is more stable. Is that clear?
Yes, sir.
Now there is a rule in this NCRT for this product especially, that is called Sadjeff rule. That is called Sadjeff rule. And what does this Sadjeff rule say? Alkene which have more alkylated part, alkylated. That means the alkene which have more alkyl part, that is more stable, more stable. As you can see, along this double bond, we have this alkyl and this alkyl. That means two alkyl. But in the above, along this double bond, we have only one alkyl part. So it is less stable, minor, and this is more stable because it is more alkylated. Are you getting my point?
Yes, sir.
Very good. Now, I'm going to show you the next reaction, that is reaction with metal. Reaction with metals. So what is this reaction with metal? Basically, this reaction or this metal from where we are going to react is basically this is your CH3, CH2, and Br. This is your haloalkane reacting with magnesium. Then it will be in the presence of dry ether. In the presence of dry ether, it will be CH3, CH2, MgBr. And this is a very famous reagent, that is Grignard reagent. And this compound is basically known as organometallic. Basically, this organometallic compound is this Grignard reagent. Organometallic compound. There is organic compound as well as metal. That's why it is known as organometallic compound. And this reagent that we always write in a short form or general formula, RMGX, or basically RMGBr. This is your Grignard reagent. Is that clear? And this Grignard reagent is very, very reactive, very, very reactive. Even a moisture can react with it to form hydrocarbon or alkane hydrocarbon. Are you getting my point?
Yes.
Okay. So moving to the next point that I told you, RMGX is very reactive. Why it is so? So as you know that this magnesium is metal which is electropositive, so it will donate electron, and this is delta negative, and this is also delta negative. It is so reactive that even a small amount of moisture can convert it into hydrocarbon, and the other product or byproduct will be this. Is that clear? So I'm going to explain this reaction. It's very easy to understand. See, this is your RMGX, right? So what will happen? This will have delta negative, this will have delta positive. H2O has two parts, H plus and OH minus. Now you know the drill, that is positive will go to negative, this bond will be broken, and negative will go to positive. So as you can see, R will have H and Mg will have OH. Is that clear? In this way, reaction takes place. So if I'm going to give you a question, CH3, CH2, CH2Br, and you are going to react this with H2O, can you tell me the name of the product? I'll be coming from Austin. Please wait. Are you done with this?
Yes, sir. You will form propane plus
Very good.
BROH. Sorry, MgOH, Br.
Very good. Now see. Words reads. You are going to make this chapter very strong because you know, Firaz, if you are going to do 100% in this chapter, it will be very, very easy uh, to study and score in next chapter because most of the concept or reactions will be repeated in the next chapter and in the next chapter also from the alcohols, phenols, and ethers. Are you getting my point?
Yes, sir.
So if you are going to give this to 100%, that means you are giving 30 to 40% for the next chapter. And if you are going to work hard in the next chapter, then it will be very, very easy to study that aldehyde and ketones because they are totally connected. In the next chapter, see what we studied here. Preparation of haloalkanes from alcohols. Okay, so this same reaction will be repeated in the next chapter as the name chemical reaction of alcohol. Are you getting my point?
Preparation from alkyl halides.
Yeah, not preparation from alkyl halide. Basically, we studied preparation of alkyl halide from alcohol, and this topic will be changed in the next chapter. That will be known as chemical reaction of alcohol. How we are going to see the chemical reaction of alcohol? Alcohol react with alkyl
It becomes a property, right?
Yes, property. And then see how we prepare alcohol from carbonyl compound, aldehyde, ketones, carboxylic acid. Then in the next chapter, it will be the property. Are you getting my point?
Yes.
So please make it strong. Odes reaction, it's very important and very easy. See what happens when alkyl halide react with 2Na. So we basically take 2 Rx and it will give RR and NX. I'm going to explain this reaction. It's very easy. Rx, I'm going to write it like this, and 2Na, I'm going to write it like this, and then XR, I'm going to write it like this, and you need to remove this salt, NaX, whether it will be NaCl, NaB, or NaI, and just add this R and R, it will give you double. Is that clear? Is that clear? Am I audible?
Yes, sir.
Okay. So this is how we do. Okay. Can you do this? Basically, whatever is the number of carbon in your reactant, that will be doubled in product.
So you'll have butane plus 2 NAB.
Yes, butane plus 2. So basically, we have studied more. Now we need to practice question. So I'm going to give some questions,
In the presence
and
of dry ether.
you are going to, yes, in the presence of dry ether. Okay. Write the question with me, please. Identify the chiral and achiral molecules. In each of the following pair of Please do let me know when you are done with this question.
Are you done with this question?
Have you written this question?
Yeah, the first one is CHS and
The first one is
CHS carriage.
this one, and the second one is this one, right? No, no,
Yeah.
not this one. This one. See, this is H different group. This is
Yeah.
CS3 different group. This is different group. This is different group. But if you are going to check it, this is twice. Now you are going to check this for this carbon. There will be hydrogen different than OH, and there is C and there is this. You are going to check this part. If you are going to check this part, this will be different. This will be different. But this and this group is same. Is that clear?
Yes, sir.
Draw the structures of monohalo products. In each of the following. Wait a minute.
Can I see the first one?
Yes. Are you done with this all?
Let me know when you are done with this. Are you done with this? Firaz?
Yes.
Okay. Let me show you the product and then you can match it. You will get as a main product, and this will be your main product. And after this will be your main product. Secondary will be more stable, and then this will be your main product, and then this will be your main product, and then this is beer in the presence of beer. Either here you can apply, here you can. Okay. So all of them are correct or wrong?